Now I'm going to introduce you the straw flute. I believe that most of you have ever seen or even played this straw flute. And now I'm going to tell you the physical theories and phenomena behind this instrument. When we play the straw flute, we will vibrate the air inside the straw and create a standing wave. And because this straw is a one-side open tube, so the wavelength of this standing wave is a quarter times an odd number. And when the odd number equals 1, and we call this a pitch, and that is the straw flute. And now I'm going to play this instrument. And now I'm going to introduce you the 12 equal temperament. The 12 equal temperament is the most common musical temperament that is widely used by most music and songs, including modern and classical. And in physical aspects, the 12 equal temperament is what we separate an octave into 12 semitones. And the frequency ratio of each semitones is 2 to the power of 1/12. So their distance actually are the same. And comparing to the Pythagorean tuning, the 12 equal temperament can solve the transpose problem that is unsolved in the Pythagorean tuning. So which makes the 12 equal temperament became the most common musical temperament. Thank you for listening.
Hello everyone. Now I'm going to introduce the singing rod. This is an aluminum rod, and when we scrub the rod's interior will create several waves of different frequencies. And then we hold the center of the rod to adjust these waves. Thus, we can get a standing wave in the rod, which now is at the center of the rod. And once we scrub the more times we scrub the rod, the more energy the standing wave is, so we can hear a sound from it. And how we control the frequency of the sound from the rod. The key is the length of the rod. The longer the rod is, the longer the wavelength of sound from it is. Thus, the frequency of the sound from the rod will be lower. And compare this one and this one. This one is thicker and longer, and this one is shorter and thinner. So what's different with this? First, this one has more atoms in it. So if you want to make it make sounds, we should give it more energy to make every atom of it vibrate. And because this one is thicker and longer, so the atoms in it is more than this one. So this may be so if you want to make this rod make sounds, is more difficult than this. And let me show you.
Hello everyone, today I'm going to introduce the saw piano. The saw piano, which you can see is made by a saw and a bar, and the saw is made by the metal. And how to perform it is when you need to use your bar to scrub the saw, and the important thing is you need to make your saw become S shape, and like this. Amazing, right? And yeah, so next I will introduce the principle of the saw, how to make it sound. It's simple. When you make the saw become an S shape and you scrub the saw, and the S-shaped reflection point, it means it is the saw's nut, and making the standing wave. So it will, when you scrub the saw, it will give it energy into the saw's standing wave, and it will make sound. And how to change its frequency is when you make the S shape more S, it will let its frequency more higher, and the sound will more higher too, like this. Okay, thank you for your listening.
Okay, now I'm going to introduce the resonant box. We find that the longer the resonant box is, the longer the wavelength in the resonant box is, so the frequency will be lower, like I mentioned above. So, but we know that the wave of sound is not horizontal but vertical. So the resonant box caliber it have something to do with its frequency. We know that the bigger the caliber of the resonant box is, the shorter the sound from the resonant box is. And now I'm going to introduce the school form. It's an application of resonant box. Because our school is actually a resonant box. So if you cannot hear sound, we can use the school form and touch here, and we can hear a sound.
Hello everyone, today I'm going to introduce the singing glass. Now you can see I have a glass in my hand, right? And how to make it sing is very simple. First, you need to put some water in it, and then dip some water on your hand to increase your friction. And finally, rub the edge of the glass, and it will make a sound like this. Amazing, right? Now, I will tell you the principle of the singing glass. It's very simple. Because you rub the edge of the glass, and the glass will vibrate. And when it vibrates, the water in it will vibrate too, and it will make the sound. This is the principle of singing glass. And finally, I tell you how to change the frequency of the thin glass. Now you can see I have more water in it, and the sound is like this. Then when I lose some water, now you can see it's lower and have less water in it. So you can hear the sound is more higher than before. Yeah. So now we know how to decide the frequency of a thin glass is defined by the water, how much water in it. Now this is the secret of the thin glass. Thank you for your listening.